Hello friends, welcome to my channel. Today our topic of discussion is equation of motion of spherical pendulum using Lagrangian equation, and I have already made many videos of classical mechanics. You can go to the playlist. I have made playlist of classical mechanics videos, okay, on different topics. So if you want to watch them, you may go through. Okay, so now before we start, please subscribe the channel if you are new to my channel, and share with your friends if you think these videos are helpful, and hit the thumbs up button. Also hit the bell icon so that you get notified when new video will be uploaded. Okay, because I am creating contents on different topics, not only classical mechanics. I have been creating contents on mathematical physics as well. You can go to the playlist. Okay, mathematical physics, quantum mechanics. So now let's start. Suppose here you see this is a pendulum. It's similar to the spherical pendulum is similar to the simple pendulum, but it can oscillate three-dimensionally. That means in case of simple pendulum, it can oscillate in this direction only, right? But in case of spherical pendulum, it can oscillate here, this way, like that, in all directions, right? So hope you have understood. So just imagine like this. Suppose you have a table, and it can be turned, right? Turning table, and here you have a stand, or suppose you have a stand here, and this is a pendulum, simple pendulum. It can oscillate this way, and this table can be turned. Okay, this is rotating. Now you can imagine x-axis and y-axis this way. This is z-axis, and along this it is suppose y-axis. So then what you will see that if you rotate this table, you can say that axis of this axis x-axis and z-axis, all these two axes are also rotating. Okay, with the table, right? Turning table. You can imagine that way, and this is oscillating this way. So if this frame of reference, used to start, if it is rotating, then imagine the motion of this pendulum with respect to this, frame of reference, with respect to this coordinate system. So it is rotating, it is oscillating this way as the coordinate system is rotating. X and z axis are, you can imagine that in this system, this pendulum is oscillating like this way, this way. So hope you have understood this concept, right? Now you see, so let me consider this length is suppose L, length of this thread of this pendulum be suppose L, and its mass be suppose M, right? Let me consider that way. So here you see, so here we have considered that as a spherical pendulum of whose mass of the bob is M, and length of its string is suppose L, right? And this pendulum will have motion in this way, right? Horizontal motion as well as vertical motion, right? So hope you have understood this. Okay, with respect to this x and z axis, it will be oscillating in this way also, and in this way also, right? So hope you have understood. That's why it is a spherical pendulum, right? So now you see, let me consider this is the angle, right? This is a theta beta angle. Theta be the angle made by the string of the pendulum with the y-axis when its displacement is maximum, right? when the displacement from its mean position is maximum, at that moment this angle is suppose theta, and we have considered that this angle of rotation of this axis is suppose phi. Okay, so here you can consider that phi is the angle between x and x dash or z and z dash, as x and z axis are rotating about y. Okay, now you see when this bob will be at this position, okay, due to the rotation of axis, okay, at this position due to the rotation of axis, okay, here is the bob now, then here you see, and this is the, let me imagine a perpendicular here. Okay, this is the perpendicular from this point to the x-axis, right? Then what you will get, then this perpendicular, this one will be given by first let me write this one. This length will be what? This is theta. If this is theta, then this component will be L cos theta, right? This component will be L cos theta, right? Then this component will be L sin theta, right? So then in that case, if this is L sin theta, if you imagine this triangle, right? If this is L sin theta and this is suppose phi, then this component will be L sin theta cos phi. So I hope that you know the resolution of vector. Okay, using that concept you will get L sin theta cos phi, right? And this will be L sin theta sin phi, right? So let me write this one here. Okay, and this side will be L sin theta sin phi, right? As this is L sin theta, this length is L sin theta, so this is L sin theta sin phi, and this one will be L sin theta cos phi. So hope you have understood this. Now let me go to the next slide. Okay, let me go to the next slide. So here we're gonna write L. So now let me write the positions of this box with respect to x, y and z axis. That will be given by x is equal to, so here this x will be given by, here you can see this is this length is given by L sin theta cos phi, right? L sin theta cos phi. So just let me draw it cleanly, just wait. So let me make it clear. So here you can see, this is A, let me consider this is A, this point is A. So AOB, this position of the bob is suppose at B, at the point B, and this is length is L here, so this is the L, so that's why this component will be L cos theta and this component is L sin theta. So we have got that OB is L sin theta, So if it is L sin theta and this angle is phi, if this angle is phi and this is 90 degree, from this triangle BOC we get this component as L sin theta cos phi, right? L sin theta cos phi. It's a very simple. Now you see this is a triangle, right angle triangle. If this is phi and if this length is, suppose this is h, suppose, and then this is gonna be given by h cos theta, right? So here instead of h we have L sin theta, and so h cos phi here, that should be phi, h cos phi, as here h is L sin theta, right? So hope you have understood this. Now you see okay, so from the triangle BOC, from triangle BOC we get x is equal to that is L sin theta cos phi, L sin theta cos phi, L sin theta cos phi, then y is equal to y, here you see this is the y from the triangle AOB, from triangle AOB. So this is y, this is in downward direction, so that will be considered as negative, okay. L, so that is L cos theta, right? So minus L cos theta, okay. So now you see z, this is the z, right? So z will be, so now you see as this is the z dash axis, and along z axis its displacement along z axis is this, means BC, okay, means BC along z axis. So z axis is in this direction, along its displacement is taking place in opposite direction, right? In opposite direction. This is the z axis, this is the direction of z axis, it is taking place in opposite direction, that's why. So from triangle BOC we get that z will be also taken as negative L sin theta sin phi, right? We're going to take that way. So now you see, so with respect to x, y and z respectively we can find the velocities, okay, velocities along x, y and z respectively. So first we have to find x dot. X dot means dx by dt. If you differentiate with respect to t, then what are you gonna get? Del L theta dot, if you differentiate cos theta, right, then you should get if you differentiate sin theta, you should get cos theta, and we are differentiating with respect to time t, that's why again we need to find d theta dt. We have to write d theta dt, which is represented by theta dot, and second function is cos phi, so this is the second function cos phi, again plus derivative of the second function. Now we are using product rule, okay, and ddx of cos phi, that's going to be negative, right? So let me write here minus sign, L sin theta, and ddx of cos phi, that will be minus sin phi, so that's why this minus sign comes. And here again we are differentiating with respect to t, so that's why we need a phi dot, that means d phi by dt. So let me write here, just let me put the L here, so here let me write phi dot. So this is x dot we have got. Now let me go to the next slide. Let me copy this result first. So here is the next slide, then the last result we have got velocity along x-axis. as this. And now velocity along y-axis, y dot, if you differentiate y, this one, if you differentiate it, minus L cos theta, y is equal to minus L cos theta. So right, if you differentiate this, y is equal to minus L cos theta, that will be minus, and derivative of cos theta again minus sin theta, so it will be plus, then L sin theta. Then again we are differentiating with respect to t, so we need a theta dot here, theta dot. So hope you have understood this. Now z dot. So what was z? This is the z. Let me copy this here. This is the z, right? So let me write here z. So if you differentiate this, taking this as u as, and this is this one as v, if you differentiate it, what you will get? You will get minus L theta dot cos theta sine phi, right? Okay. So if you differentiate this first function cos theta, then you should get, so if first function is sin theta, if you differentiate it, you should get cos theta, and as we are differentiating with respect to time t, so d theta dt, right? That means theta dot, right? So d theta dt is nothing but your theta dot, right? So again, differentiate the second function. Let me write the first function as it is, L sine theta, and if you differentiate sine phi, then you should get cos phi, and again we are differentiating with respect to time t, so that's why what we have to do, let me put this one here. So that means again we need to write phi dot here, we need to write phi dot here. So hope you have understood this. We have got all the three velocities, right? So now you see, let me clean these things. Okay, so now you see, we know that Lagrangian L is T minus B. T is your kinetic energy, right? Kinetic energy is given by half m v square. Here instead of v square, we have to take all these squares of this velocities, sum of the squares of this velocity. So m x dot square plus y dot square plus z dot square, all components should be taken, right? Now you see, this is the kinetic energy, and if you use those values, if you put those values here, then what you will get, let me show you. So then t will be equal to half m, and here you will get L square theta dot square cos square theta cos square phi plus L square phi dot square sine square theta sine square phi dot, sorry, not phi dot, phi minus 2, then that means we have used here a plus b whole square formula, sorry, a minus b whole square formula, that is a square plus b square minus twice ab. We have used this one here. Okay, so then L square theta dot phi dot, and let me write this one on this side with minus 2 L square theta dot phi dot and cos theta cos phi sin theta sin phi, then plus L square theta dot, again if you square this one, L square theta dot sin square theta you will get, then if you square this one z dot, then you will get L square theta square cos square theta sin square phi plus L square theta dot square, sorry, not theta dot, phi square L square, here it is phi square, and sin square theta cos square phi, then plus 2 L square theta phi dot cos theta sin phi, then sin theta cos phi. So here you see, if you observe it, then you can see clearly that this term and these two terms are equal but opposite in sign, so we can cancel these two terms, right? We can cancel them. Okay, let me cancel these two. Okay, then what you can do, you can take commons. Let me show you. Here you can see, you can take L square phi dot square sin square theta, L square phi dot square sin square theta common from these two terms. Then what you will get, then L square phi square sin square theta on taking sin square theta common. Within bracket you will get sin square phi and cos square phi plus cos square phi. That's gonna give you 1. This is gonna give you 1. So at the end you will get, and you will get from these two terms L square phi dot square sin square theta. That's what you will get, right? And from these two terms you can see L square theta dot cos square theta. Okay, then L square theta dot cos square theta. From these two terms you can take this L square theta dot cos square theta common, then you will have cos square phi sin square phi within bracket, that's going to be equal to 1 again. Then your answer will be L square theta dot square cos square phi. That's what you will get, right? Sorry, not phi, theta, cos square theta. Okay, now you see, from these two terms you can take L square theta dot square common, right? So let me go to the next page. Okay, so let me copy these things first. So here what we have got, half m from these two terms, this one and this one. What we have got L square phi dot square sin square theta within bracket sin square phi plus cos square phi, then plus from these two terms what we can write, L square theta dot square cos square theta, and within bracket, let me write this one below. Within bracket you must have sin square phi cos square phi. Which is also going to be 1, right? Then plus L square theta dot there should be square, I think. Yes, it should have been square. Okay, sin square theta, right? So this 2 becomes 1. So let me close the bracket. So here t is equal to what we have got, half m L square phi square plus, so here phi dot sin square theta, this one, and plus here this one we have to write L square theta dot square cos square theta plus then L square theta dot square sin square theta, right? This last time. So from these two, what we can do, from these two we can take L theta dot square common, right? So let me go to the next slide. Let me copy these things. So what you will get, half m, so let me take ml, this, wait, just, you can take L square common, right? L square common, and from these two you can write theta dot square common. Then here you will get cos square theta plus sin square theta, right? And then here we have phi dot square sin square theta, right? We have got this one. So now it can be written as half m L square, so theta dot square, this becomes 1 plus phi dot square sin square theta, right? We know that Lagrangian L is equal to T minus V, and V is equal to, so that in this case here you see this is the pendulum, right? This is the y-axis, and V should be like this, potential energy. So it must have potential energy, so that's going to be given by, as it is going upward along y-axis, that's why mgy, that's going to be given by mgy. This is the potential energy, not in here, this is the potential energy. And so mgy is minus L cos theta, minus L cos theta. So that's why V becomes V is equal to minus mg L cos theta, right? Mg L cos theta. Now if you put the value of T and V here, then what you will get? Then you will get, let me go to the next slide. Let me copy the results of T and V. This is T, so here is T, and what is the V? This is the V, so this is V, right? Therefore Lagrangian L T minus V, that's going to be equal to, if you subtract this to T and V, then you must get half, just you can copy from here. Let me take the copy. Let me copy from here. So then minus V, as there is minus sign, and this minus will be plus, right? So we're going to take plus cos L theta, so here it will be plus, right? So hope you have understood this. So now expand it. If you expand it, then your L gonna be half m L square theta dot square plus half m L square phi dot square sin square theta plus mg L cos theta, right? You're gonna get this. So now Lagrangian equation. So Lagrangian equation is derivative of partial derivative of L by q dot I, then its time derivative minus del L by del Qi, that is equal to 0. This is the Lagrangian equation. First let me find this one. So here we're going to take Qi. In the first case we're going to take Qi as theta. Okay, so then del L by del theta dot, del L by del theta dot. Okay, first let me find del L by del theta dot, then what you gonna get, right? Here you see only this term contains theta dot, that's why if you differentiate it you will get half m L square 2 theta dot, right? These two cancels, you will get m L square theta dot, so remaining will be 0. Okay, then del L by del theta, first this one, this del L by del Qi means del L by del theta here in this case. If you find that one, Then here you see you have to differentiate only theta only. So sorry, theta, terms containing theta. So here second term and third term can be differentiated. So for if you differentiate partially, so then what you will get, half ml square phi dot square, and derivative of sine square theta, that's going to be 2 sine theta, and derivative of sine theta, this is function of function, that will be cos theta, right? That will be cos theta, and here these two cancels. Then derivative of mgl cos theta, that's going to be minus mgl sine theta. Derivative of cos theta is sine theta, right? So that's what we go to the next slide. Here you can see these are the results we have got. Now let me find the t of del L by del theta dot. If you find that, then if you differentiate it with respect to time t, then you will get ml square theta double dot. That's it, right? So now using these results in this equation, right, in this above equation, so let me write this as equation number 1, using these results in 1. If you use those in 1, then you should get ml square theta double dot minus ml square phi dot square sine theta cos theta plus mgl sine theta is equal to 0, and dividing both sides by ml square, dividing each and every term by ml square, you will get theta dot square, sorry, only theta dot, not square, then minus phi dot square sine theta cos theta plus q by, sorry, not q, g by l sine theta is equal to 0. So this is the first equation of motion, first equation of motion of spherical pendulum, right? So we can obtain another equation of motion taking qi is equal to phi. If you take qi is equal to phi, so here you see, this is one equation. So if you take qi is equal to phi, let me go to the next slide. So now taking qi is equal to phi, then what will be the equation of motion in that case? Here you see, so let me write these things first. What is the L we have got? So this is the L, right? Let me go to the next slide now. Here you see, this is L. First let me rearrange this thing. If you take qi is equal to phi, then this is going to be your Lagrangian equation. Here we're going to use the you see here what we're going to do, del L by, first let me find del L by del phi dot, okay, and its time derivative as well, right? If you find del L by del phi here, so you can differentiate only this term, because other remaining terms will be 0. Here only this term contains phi. If you differentiate it partially, then you should get half ml square 2 phi dot sine square theta, then these two cancels, right? Then again you need to differentiate it with respect to time t, right? Again you differentiate it with respect to time t. Then here you see, if you differentiate it with respect to time t, then what you will get? Then you will get ml square ml square, then here you see phi, this is the first function, derivative of the second function, that will be 2 sine theta, and again we are differentiating with respect to time, so that's why we need a theta dot, okay? So that's why we will write this one as like this, theta dot phi dot 2 sine square theta. That now plus again ml square, now we will differentiate the first function, that is phi theta double dot sine square theta. That's what we're gonna get, right? So now let us use this result here. Okay, we have got terms only containing phi dot, not phi. There is no phi, that's why this term gonna be 0, right? So that's why here del L by del phi, here it will be 0. So using these values in 2, suppose this is equation number 2, so we will get, just put the equation, put these values here, and here it will be 0. Then our equation will be, first let me copy these things, ddt of del L by del phi dot. Let me copy this result first. Okay. Just wait. Okay. Copy. So this is the result. This is what? This is nothing but time derivative, okay, of del L by del theta, del phi dot, this one, right? So what we need this del phi dot minus del L by del phi, right? So as del phi is equal to 0, so this is the time derivative of del L by del phi dot. So that's why we have to put here 0. So our Lagrangian equation will be equal to 0. This, right? This will be the Lagrangian equation. That means what we have done here, you see, we have used these values, use these two values in this equation number 2, right? So now divide each and every term by ml square, then you will get phi dot theta dot 2 phi dot theta dot sine square. So let me write it clearly, 2 theta dot phi dot sine theta. And one more thing, this sine theta should be also, we should find the differentiate of sine theta as well. So let me go to the previous slide. Here we have sine theta, right? So if you differentiate sine theta again, this is function of function, then you should have got cos theta as well. So here we need a term cos theta as well, so I missed that term, sorry for the mistake. So here it should be cos theta, should be here, there should be a cos theta. So hope you have understood this, cos theta, then plus phi double dot sine square theta is equal to 0. Then if you divide this whole equation by sine theta cos theta, then you will get let me divide both sides by sine square theta, not sine theta whole sine. Then if you divide this one by sine square theta, then you will get sine theta into sine theta here. So sine theta will be cancelled, and sine by cos, that will be cot theta. So here we will get cot theta, and on the other side we will get phi double dot on this in this term, right, dividing it by sine square theta. So this is the second equation that we needed to find. This is the another equation of so let me write it cleanly. So this is the second equation of motion of spherical pendulum. So hope you have understood this. So if you like my video, please share with your friend, hit the thumbs up button, also subscribe the channel if you are new to my channel, and see you in the next video. Stay connected. Thank you.